fast version, Linux Crash Course, Bash Shell. You're learning that now because we will need it for the entire week. And hopefully you have already set it up, running in your SSH client and so on, that you can work on the cluster right now. I will show the commands I'm showing in the exercise in the slides right on the left side in my shell, which is also just using a simple the same trainings accounts you're using plus some files I had set up before. So it should have a very similar experience if you do it on your own. And my goal for this is that you do use the shell, type something in, use some commands, get used to it. You don't need to remember 100% of the stuff I'm talking about right now, but if you lose the fear of working with the shell and get used to it, that is my goal. So at the end of this, I want you to be able to connect with SSH to the system, or you should already be able to do so. If I helped a few of you in the meantime, then you should be able to navigate that system, get comfortable with a text editor, and at a later point, I will also talk a bit about Git, which will be especially interesting for the students taking this course and how they will be graded, because they will hopefully use Git for that follow-up project, but later, more on that later. Okay, so a bit of context. I will focus on the most important commands. So the shell is like full of commands. You can do so much stuff in here that even I don't know all. So I will only go over the most important stuff. I also understand that not all of you are beginners. There are a few of you, or more of you, that are already used to working with the shell and come here for the parallel computing part of this course. So I can't teach you much more, so the basic part would be boring for you. In that case, I want you to work through this course on your own pace. Also, my course, this 2-hour section on your own pace. You can even mute me if you want. Just look at the link I shared. There, if you find an exercise and the slides, go over the slides, go through the exercise. If you find that you are lost, you can just come back here and join the beginners. There's no shame in that. Yeah, so the exercise includes some parts as follow along for the beginners. You can open that and you will see that the sections match the sections I have in my presentation here. And I will also give some time for completing those follow along exercises. There are also some advanced exercises for the advanced users among you. So hopefully no one gets bored from looking at a terminal. Also prepared the slide deck in a way that you can hopefully use it as a lookup during later stages of the course. So if you're ever wondering how a command was or how it was used, you can just look through this. It's all mapped in here. And yeah, so another important thing, this red box, I use it to mark things that I find important or that should go into the basics. If you find a box that is blue, you can remember it, you don't need to. So, hopefully you have all found the exercise sheets by now and have at least downloaded them. Just a quick reminder to join the breakout room, but I think everyone managed to do that in the first session. So, okay, so let's get into the material. What is a shell? The shell is what we're looking at on the left. It's a command line interpreter. So I can type in commands and it does it. So that's a command line interpreter. I just type in commands and it executes them immediately, or at least it tries to. So I can only enter them via keyboard. There are no buttons on the terminal itself. This is on the shell itself. This above here is my terminal emulator. There's some distinction there, but no one will be mad if you confuse shell and the terminal. So, but to state it once, this above here, this window where I can do some stuff with it. This is a terminal, and this is within it where I can type my things. This is a shell. I can still use my mouse for copying stuff, but besides that, it doesn't do much. It's since there are no buttons. And with the way it works, I can start other programs in this shell. So programs typically only run inside this shell and only print the outputs in the shell. Sometimes they can also start another program that opens a new window, which will be a few times the case, but mostly it will run in the shell and put the output back into the shell. So also some quick ways to open a shell if you or at any form of terminal. If you're on Windows or macOS, but you should have your SSH shell open right now. So this is the contents of the course. You can also read at the top. I will not go over it right now. Here for reference is the SSH client setup and how to connect with it. You should have done that by now. If you have still trouble, just write in the chat and some of my helpers will hopefully come around and help you set it up. And okay, so let's get into the basics. So the most basic stuff is that we are lazy. We are super lazy and we don't want to type. We want to avoid typing things that we have already typed or that are obvious. So we have to have an autocomplete feature. We can type in a command, like say, I don't want to type in sleep. I type in half the command, I press tab and auto completes it. And I can also press double tab. In this case, it just lists my files because I haven't started typing a command. If there are multiple options for a command, it will list all of them. Okay, so another thing I showed earlier is if I type in a command and I want to stop it because for some reasons I want to interrupt it, then I can press Ctrl+C on my keyboard. It's shown like this. The symbol commonly represents control on the shell as a symbol. Or I want to repeat a pass command, I can just use the arrow keys to go up and down through the pass commands I used. And if I want to clear all this mess up, I can just use clear. I want to exit right now because it would kick me out of my SSH session. So yeah, that's how you close your session correctly. Not just closing the window, tell the system I'm done, bye, and this is what you do with exit. But I can show it this way. I just open a shell within my shell. It's also possible. And just exit out of it again. So that's how you can use exit. Here are some more advanced shortcuts. You can verify that they work. I won't go over them right now, but they are here in the lookup if you want to learn them. They might be interesting for the advanced users because I'm sure not everyone knows all of them. I sure don't know all of them by hand. I also get used to using some of them. Okay, so folder navigation. I'll just go from top to bottom. We have PVD or print working directory. Just prints the full path to my current working directory. So we have the path to our user stuff, and I've prepared an additional folder called shellx where I prepared some exercise thingies. These include a few files and folders. So this is a normal list view, like ls stands for list. You can also add a, then it lists everything, and this includes stuff that starts with a dot. This dot marks hidden things. In this case, just a simple dot marks the folder itself. Double dot marks the parent directory. So there are links to the parent to the directory itself and to the parent directory in here. And also list another file that's hidden because I put a dot at the beginning, so it wasn't listed before. Then I can also get another view. So let me use LA view. We get the long table form. What all this stuff is, I will get to in a moment. But it gives a lot more information than you can see in the above version. I can also list a specific directory instead of just the directory I'm in right now. So if I say I want to see what's in projects, oops, I can say ls, put my flags in here, and then just append projects or the folder I want to see at the end. I can even do it for my parent directory. Let me say parent directory, and then there's my parent directory. Okay, then changing directories. So that's what the cd command is for. If you're on Windows or something, it might be dir for directory, but we are using dir here. So if I use double dot, I move to the parent directory. So like, I want to go to a specific directory, I just type in the name or type in half of it and press autocomplete. If I want to go to my home directory, that's this directory here. That's based on your user account. You have your own home directory. I can type in this tilde symbol. This will always reference the home directory. So if I want to refer to in a longer path, like say I want to go to my home directory and then to the subdirectory shellx, then I can use tilde, slash, and so on. If I just want to move to it, I can also type just cd, and it will always move me directly to my home directory. So then there's also a thing that Linux or the shell really does not like spaces. That's because we use spaces to differentiate between our arguments and our commands. So if you need to group multiple things into a single argument, say want to change directory into shellx, but the sum for some reason would have a space in it, then I need to put it into these symbols, whose name I don't know in English, Anführungszeichen. You know what I mean. There's also a slight difference between them and quotation marks. Thank you. It's already an interactive course. Yes, I think hyphens are the short ones. Those ones that they work the same for the most part, except when they do not. So okay, okay, that's obviously not shellx for directory, my shellx directory, so I would have to go this. Okay, then if you ever need help with a command, you can do so with, and you have a few options. If I, for example, want to, most commands have a simple usage dialogue that I can show if you add append help, -h, or just type help, depending on how the command works. And there's also man or manual. So if I have man is also a command, so I can say, okay, I want help with it. I put in man -help, and I get this usage dialog, which shows me all the options I have for using it. So this is pretty abbreviated, I would say, since it just gives a one-line explanation for what is what in here. I can also get a longer explanation of it. If I type, for example, man, I get this window. This is like if you would have a physical manual where you can look through it and the pages, this is a digital equivalent to it. And most commands do come with something like that. So here I have a long description of it. You also notice my terminal has changed a bit. I don't have this bar asking me for new commands right now. This is what is called a pager. And I can navigate it with my arrow keys or with my scroll wheel right now. There should also be page up and page down. I can jump a single page. We will have other pages later on, so should get used to their commands. And here I have a full explanation of all what this command does. There's even a search feature, I think was control. Okay, I would have to look it up what the search thing is. There's also a help thing for the page there, so you can also find that. And obviously, if you are really stuck with something, you can also just look things up on the internet. Okay, if you have still a problem with the SSH key, probably if one of my colleagues will get to you. I don't want to discuss it in the forum right now. Okay, so about what I showed you earlier, this long table format. So file and folder permissions, you don't need to know about them until you need to know about them. A few of you already had to learn a tiny bit about them because these SSH keys need to be in a specific form or the client will complain. So if I do the s-la, I get the long table format, and this is the same as shown here. I get these fields that indicate the permission on the file. This is the link number, my user, my owner, my group, the size, and modification date and the name. So from left to right, we have the first symbol, which shows the type as here. In this case, it's D, so as in directory. A for most of them, except for this one, which is a file. And then I myself have read, write, and execute permission on them. That's what this marks here. In exam solutions, I don't have permissions for security reasons right now. And my group and my others do not have any permissions. This might differ from the command I showed you if you have given you support in the what's called for the SSH key. They used the chmod key with or changed chmod to modifications with something like 400. Here I show it to you with the more obvious form in a second. So there's these both ways. I won't cover the number format because it's a bit more complicated to get into and less obvious. So, but they're equivalent in power. Okay, hopefully this is clear what this table format shows. There are also some other thingies that work somewhat different for directories and for files, and they get somewhat complicated, but you won't need them in 99% of the time. So if you're not interested in them right now, you can just ignore them. So changing modifiers. Let's go over it with an example. Let's say I want to look into like some solutions. If I want to try to switch to the directory right now, it gives me permission denied, even though I'm the owner of it, because I don't have read or write permission on my own directory. So I need to use the change modification chmod command. The command structure looks like this. I need to give it a target, or need to give it a user that I want to change. This is uses the abbreviations, either U for user, G for group, O for others, or A for all. Below you can see here I would change for all, here I would change for only group, here I would only for user. Then I need to say what I want to change. Do I want to add a command? Do I want to remove? Do I want to add permission? Do I want to remove permission? Or do I want to set permissions to something? And then what permission I want to change. So I can change read, write, or execute. If I say, for example, equivalent, and then I append nothing, like in here, I would say, okay, group has no permission on it. It would remove all permission. And then, of course, the target, which can be a file or a folder. If I want to have it affect all the things in the folder, I need to add this recursive command in here. So if I want to read my exam solutions now, let's see, I would say I add read permission, to exam solutions, of course. Can I change to the directory now? I still can't change it. Why can't I change it? Oh, because folders are weird and also need to read write permissions, I think. I still can't change it. Okay, so to open a folder, I also need to execution permission. It's weird, I know. But then I can open it and I can find the solutions. But I won't open them. But because we are not there right now. We don't know how to open files right now. We only know how to navigate it. There's also these commands, change ownership and change group. You should remember that they exist, but you probably won't need them for this course. I think. Maybe. They exist, so we can also change those. And there's also a thing called a super user on Linux system, which would be the administrator for a Windows system. I'm not sure if macOS is equivalent. I think they also, since they're Unix based, also have the same system of a super user. And the super user can execute commands as has all permissions on the system. So, but it's dangerous because if you have all the permissions, you can break things really easily. Because normally it'll stop here, hey, you don't have permissions to use it. So what we are using is this sudo to give permission to it, to execute command as root. If you're on your own system and you are your own admin on your own system, you can use this command and it will query your password. I'm not admin on the HPC servers, so I won't be able to execute. So if I try to sudo something, it will query for me for a sudo password, and I won't be able to answer that. Okay, there are also this funny comments. So if you guys are on the system right now, should be able to see lots of HPC training accounts here. I can check here, a few guys of you are on here. There should be a few more. Like where's HPC training 1 to 40? There are only a few of you. It's all in the open. I can see what you guys are doing, by the way. And it's what everyone can see. just type in W and it shows what everyone is doing right now in the system. It's in that sense an open system. Yeah. So if you're not having don't have a terminal open in front of you right now, I suggest you get to it and try a few of those commands I just showed you. I will go over the Nano stuff right now, so you get to know a terminal editor, and after that I give you some time to follow the exercises on the website. I will link to them again if you haven't found them yet. So if you want to change files, like let's say if you want to have a look at the exam solutions I just showed, then we need, or want to change them, then we need an editor. So there are a few editors out there. There's Emacs and Vi and Vim and so on. And there have been religious wars about what of those is better. So we ignore all those and go with Nano because Nano is easy. So if you want to edit a file, I just type in Nano and the file's name. In this case, solutions. Oh, look, the solution is studying. Yes, I know. And just get to drop into an editor. I can make changes first by type stuff with my keyboard. I can navigate with the arrow keys. I can also copy stuff with my mouse, as you would do in the terminal, and so on. I also can have a few shortcuts in here. They are covered on the next page. Like what you expect, like copying stuff, cutting stuff, and so on. These two things we need to remember right now is Control O for save as. It's a simple save file as, and then you can enter a file name dialog you should remember from other similar tools. Then I confirm the file name and it's saved. There's also the Control S command, which is weird. Of course, it works on most systems, but does not work here because we have an old version of Nano. And for historic reasons, we get this answer that no one knows why it is here. If you find it out, tell me, because I don't know. It's lost in history. Okay, so normal system Control S should do something meaningful. Here it just outputs this command because shells are weird. And if I'm done with it, I can Control X. Oh, I made a change after saving it. So it will ask me what to do with it. I will say I will preserve the change, so I get the save dialog and it's saved. So that's how you use an editor. There are a lot of shortcuts for it. And I will just leave them on the screen if you want to try them out. They're also in the slides if you have found them by now. And yes, please look at the exercises now. Just a simple follow along. I would say I give you 3 minutes or until 47 to go through them. So that would be, no, that's the wrong one. This one. No, that's also the wrong one. God damn it. This one. Now I found it, yeah. So folder navigation, help, permission, and Nano. Before we move on with environmental variables. So if you haven't found the sheets by now, it's
Jonathan, can you show maybe X2Go? How this needs to be set up? Some people have issue.
Okay, sure. I have X2Go on my system here. So this is a configuration. Others who are already done with it can already move on with the exercise. Also, if you want to close, yeah, Control X. Just Control X out of it as here. So yeah, this is my X2Go setup. I have the account 75. Need to set the address of the system here, my login name here. This sets the path to the HPC key, to the SSH key. For me, it's in a subfolder for this project. And then I need to enable this proxy, which opens this command below. That's the login.gwdg .de as the host, because it's what we are jumping into our system into, VZ. Set the same key, set the same login, and at the bottom I need to set single application and terminal. This might, for my testing, it looks slightly different for other versions of it, but still need to enter single application and terminal. Yeah, it's all on the screen when you use Nano, how to use it. Even it's a very friendly tool. It asks you and it doesn't trap you in hell like Vim does. Because exiting Vim is one of the favorite questions on Stack Overflow, I heard. So if you have entered this, you can also change the size you want your output window to have on the input-output. But you can also just keep it in the standard settings. And with that, I can say HPC training, it will auto-complete it. If I enter the first key, press enter. The password twice. Oh, and even as a session from last time, I can resume, I think. And it's connecting to it, yes. And oops. Okay, I had it open for a second, but then it kicked me out. One moment. Need to connect to it again. So. Now it works. Okay. I had to clear the old session. So this, I get this X term window, and what it can do, what my other terminal cannot do, is I can say, for example, module load Vampire, because Vampire is a graphical program, and start it, and then I get another window like this. This would not happen if I would do it with a normal terminal. So this is why we need X2Go for a later stage when we work with tools such as Vampire that have a graphical interface. Okay, it's already 49. Then I would like to move on with the slides now. Hopefully you're caught up by now, or at least you were able to follow along with the Nano and the parts before it. So looking at environmental variables. So similar as when you are programming, we have variables can also have variables in the shell where we save values. And one value is, for example, where our home directory lies. And just query that with echo home. So the thing is, the command is called, variable is called home, and if you want to access it as a variable, you need to press this dollar key symbol before it. Echo is also does what the name does. It echoes whatever comes after it, after expanding it. So you can also do some formatting stuff with it. For example, there's this pass command, which shows where it should look for your applications. This doesn't look nice to look at because this has multiple lines and separated by double dots in between. So you can use this command here to make it a bit clearer. You don't need to understand why it's formatted like that. Just if you want to look, have a nice look at pass, you can just touch it in. Does not look pretty right now. Does not look pretty. Did I miss something? Oh, I missed the end at the line. Okay, yeah, now it looks pretty. So we can also see all variables, environmental variables that we currently have, which are a lot. If I press set, So scroll down here. For some of them, there's even entire scripts in these commands, so there's a lot of space in them. So you can do something that I will explain later, but if you want to look through them, like and see them, so there's all the stuff here. That's all environmental variables that are saved. Like I could query. All of the stuff is environmental variables. So if you want, also I want to add one, you can use export. For example, I say export hello. I say hello. The important part here is that this there has no spaces in between. So if I put a space here or here, it would not work. Well, it must be just like that with no spaces. It also down needs a dollar symbol in front of it if I export it. So I export it like that. Use echo. Hello. Get my hello back. Then unset hello again without the symbol, and then echo. It's empty because I just unset that variable. If I would also leave my session here and I just had exported some environmental variables, they would be gone because they bound on to our current SSH session. So don't save your outputs in environmental variables. They will be gone the next time you open a session. There's a way to persist settings because there are files that are loaded by the shell before you start them. Started. Already prepared this beforehand. So there's bash profile, which is loaded whenever you log into your shell. And it well, you can just put shell commands in there that should be executed before. If I want to put export hello hi in here, it would load it before my session starts. In this case, I put in a weird command that does something else because it loads another file called bash rc. This is why is this so complicated? Because it's the way everyone does it. It's not a good explanation, but just follow with it for now. So in this case, this is my bash rc. And in this thing, I can put commands that will be loaded for my session. For example, I put some aliases in here. For example, I put in ll as an alias for ls-la because I don't want to type those extra 4 symbols. Just press L twice. An alias is a shortcut for another command. So if I type in ll now, what the fuck is this? And it's probably because my X2Go session runs right now. So I get this overview. Let's go to shell X where we don't have this blinking stuff. Let's get this off my screen. Okay, so this is what bash rc is for. You can set it up if you are lazy like me, but you don't need to. You can live without using aliases, just typing the full command every time. There's also a way to customize this prompt here. I won't go into it right now, but for those that have some experience and want to try out a bit, they can try setting this one. And okay, so what else can we do with files and folders? We can create new ones. For example, there's this touch command, which actually has another purpose, but I use it for creating new files. For example, I want to create a new file. Let's say I want to create a new file, new file.txt. I would say touch. Then if I look in here, there's a new file.txt. Also, the interesting part is this also is sensitive to spaces. So if I would use it like this, it would not complain. But when I look at it later, I see I have a file new, I have a file file.txt and new file.txt instead of what I would expect that I get a single file with this name. So now I can have a lot of new files that I don't need. I can clean this up using the rm or remove command. So let's say I want to get rid of this, rel, and also of this. Yes. Oh. I did not like that one. Yeah, autocomplete is also nice for using this, because the other way to get around putting the quotation marks around it is to use an escape on the white space. So it knows, oh, this following is a white space inside the command. Yes, I would like to remove that one, and they're gone now. Okay, the other thing is you can also not only create files, but also folders. Here, new folder, then I have a new folder, new folder. And I can remove them with the move near command. So there's also this remove -rf command that I want to be very careful with, because whatever you delete with it, this is gone. There's no undoing of it, because there's no what's called basket or whatever, where no bin, or what's it called on a Windows, where your deleted files go. They're just gone. So be really careful with that, because people only got quite close to losing their jobs over misusing this command. So yeah, be sure that you are in the right directory if you're going to use that one. There's also the option to copy stuff. So I have a file called manual.txt. If I want to copy it, I can just copy manual.txt, and I give a new name for it, manual2.txt. So now I have both of them. I can also copy entire folders. So if I want to say I want to copy my projects file, I say copy with R, projects, and I call it projects2. Of both of them. So one way to use use R, F, is I want to get rid of projects2. Yes, you have a question? Oh, okay. Okay, so I can also remove my manual, or I keep it around. And then there's also the move command. So we don't have a rename, and so we just use our move command for the same as we do for renaming things. So if I want to rename manual2 to manual3, I just use move. So now it's manual3. I can also move stuff into folders with that. So if I want to move manual3 projects, I do it like that. If I want to move it and rename it to manual4, I can also do it like that. So if we go to projects, then I have manual4 in here right now. As you can see at the bottom left there. Make this a bit bigger. Okay, maybe it's a bit too big. So these are the basics of file, folder, creation, deletion, moving. You probably will need those quite a few times if you're working on a shell, because there's no nice drag and drop file navigator for you for now. Also a few comments to understand the disk usage of the files you're using. And for example, you can see if I want to use DH means U, disk usage means H, DR. Some solutions are taking 32 kilobytes, projects 128. These are not the exact sizes of them, as you see with H, here, which are a bit more exact. Okay, they are calculated differently. These are because in this case, it ignores the size of the folder on the system itself. Yeah, okay, let's move on. Now, we have learned one way to interact with files, which was via the nano command. We can change it, but there are also others. Because you don't always want to have a text editor. You can use this basic command called cat. It's pretty nice. It just dumps the content of the file to the folder. You go to exam solutions and we have our solutions file here. Say cat solutions. It just dumps all the stuff I had in this file to my terminal, to my shell. So if it's a short file, you can just quickly dump it in here. So the other file opens the manual. It's a bit bigger. It just it goes on and because it's just the manual of man that I just printed into a file. So if I want to have a better overview of that, I can use the less command. So less manual in that case. And this looks somewhat familiar to the man thing we had earlier, because this also is a pager. Uses, I think, even exactly the same shortcuts. Does not look as nice as. Does it look better? It does look better if you use man, but it works quite well, I think. So I can scroll up and down with arrow keys here, or with my mouse wheel, or with page up and down, or build auf and up on your keyboard. So that works. There's also we can also search for files. A few options to do so. One is, for example, find. One say I want to find names with things with txt extension. I have quite a few of those. So I just what I did here is find. I press dot as my path. So I should look in this directory I'm in right now, and the in the subdirectories, which is successfully did here, projects, documents, and so on. And looked in the subdirectories and found all txt files I've got in here. There's also the option to find something specific inside a file. This is where grep comes in. For example, I want to look for, say, what could we look for in here? So let's look for the word manual in manual. So what we see in our output right now is that it found all lines that contain the word manual. It highlighted that word and printed the entire line that contains that word. So if I want to say look for another word, let's say display. It gives me all the words, all the things containing display. You can do a lot more with grep. These are just 2 examples of it. You can look for entire words, even use regex if you're comfortable with that. And even if you're not, you can still use it. So right now I'm only looking in a single file. So if I want to look into multiple files with grep, I can use the recursive command. For example, let's say I want to look for email, or like the @ symbol. I found quite a few emails in my stuff. So there are a few emails in manual from the creators of it, and it's also my own email, which I saved under emails. And there's also a hidden thing where I tried to search but got permission denied. So locate is pretty similar to find, just a bit simpler to use. Or you don't need this stuff because find also can do some other things. There also is head and tail. So if you're in the middle ground between using a pager and dumping it to terminal, like with a manual, I just want to see the top lines of it. For example, if I have a huge log file and I just need to see the start of it or the end, then I can use head to get the first 10 lines, or tail to get the last 10 lines. Also option to, I think it was with n, yeah, to get to state the number of lines I want to get. So with tail minus n here. Why I'm pointing at my monitor with my finger, that's, you can't see that. With minus n 20, you get the first last 20 lines. Of course, I said it here. If you don't state anything, it just uses 10. So there's also this diff command. If you have 2 large files, I want to see what's the difference between them. For example, if I go into projects where my other manual is, I say open it, make a few changes. I add a few lines, I remove a bit, then I press Ctrl O, confirm, and X, and then I say diff manual and projects manual. It says, oh, difference is, yeah, this name is missing and these 2 are in there. You can also get a bit more readable outputs if with a few more flags in here, but this is just the basic usage of it. Okay, so I think this should be more or less the most important part, besides the Git part. There are quite a few chapters left, but I want to go over the next few exercises for now. So we've covered the nano part. So I want to complete to follow along and do this. You can do this as a short with the bash rc stuff. If you don't care about it, you can just skip it. The find folder operations, the reading and searching, and yeah. let's say I give you, let's say until 10 after, 11:10. And then I will move on with the next part, processes and systems and redirection. I think redirection is pretty nice. It's a bit complicated, but it's really nice to have it. Even, but if you have followed along so far and I haven't lost you yet, that's already great. So you should be able to handle most of it, most of the exercise, the stuff you will encounter this week. If you have any questions right now, just put them in the chat or unmute yourself. Oh, yeah, you can find the slides on the web page under agenda block seminar Monday for the current time slot. Interesting question. So if I would just do hello, like say if export hello equal to hi. So hello, it does hi. Okay, we can confirm that. So let me unset hello. It does nothing. Okay, so if I leave out the export, just do that. Also works. I would actually need to look up what the main difference between it is. Okay. Thanks to Stack Overflow, it says export makes a variable available to subprocesses. So what are subprocesses? Nothing we know about right now because yeah, it's still the same right now because we're only using one process right now. But if you ever run into trouble because you're starting other command, I think I can even make an example of it. Yeah, I have an idea. So right now we have it in our just like that. So if I say bash now to get a shell within my shell and say echo hello, you get hi. Okay, my example doesn't work. Oh no, I don't. Okay, I'm actually not sure why it does not work. So yeah, good point. It actually does work like that. Like that. Someone who knows more about shells might be able to give a better answer than I do. Okay, it's 11 past 11. So I checked with the time plan, and there's actually a break schedule for some time now. So I think I would put that now until, let's say, 15 after. We'll stop the recording for the time and remove or continue with the rest afterwards. So yeah, break until 11:15. I just noticed I haven't restarted the recording. So hello recording, you have missed a bit. I'm sorry. We're at Git now. Okay, so we're using Git in a top-down fashion. We are teaching it in a top-down fashion right now. What you need to understand is if we write software and we make a change to it, the change might break our program, or not, or break it in some cases. So we want to be sure that we manage those differences between changes. That's where we introduce a checkpoint system, and we call that version control. And Git is just such a system, and everything that is inside a Git repository that is tracked by Git. For example, if we go into a Git exercise, this is a folder that I've tracked with Git. That I want to track with Git. I will show how to set it up in a second. And we have this concept of Git commits. This is essentially those checkpoints we make. Before we can make a commit, we need to stage those files. So I will show it in a second with the example. And then we can go, jump between those commits. If we say, okay, we make 5 changes and commit all those in a single commit, then we make another few changes, commit those. I want to undo those few changes I did earlier, or look at how the system looked before. I can revert to a previous commit. It's also really nice for synchronizing your work with your colleagues, because the classic use case is you're in a group work, multiple people work on the same project, and at some point you need to put your results together. And that might be a bit complicated if you have changed the same files. Git helps a bit with that, especially with remote repositories. So, okay, looking into how to use Git. The GWG DEG provides a GitLab instance. This is one version of a full-featured Git platform called GitLab under this URL. And there's also the now Microsoft-owned GitHub, which you might or might not know, or want to use or already be using, depending on what your stance is about Microsoft owning things. And so, in case you don't want to use it, we just recommend this one, because it's owned, managed by the GWG DG. So we can check git version with git version. So this version command also, by the way, works for most commands similar to the help one. You can just check what version it is. Sometimes you have to use, like I think with SSH, you have to use a big V flag like this, but it works for most programs. So we can say git init to initialize a new repository. If I use the long command ser, it created a new folder here, .git, inside of which it will save all its configuration and checkpoint stuff it needs. And we can use git status. Right now it shows us we have one untracked file on our main branch, and we can use git add to add this file. I already created a README file. It's common to add such a README file as a basis of a project to describe the project itself and what's going on there. So if someone looks at the repository, it sees the main page, it sees a README file. Oh, this project does this and that. So I added it. Now if we look at status again, if it says changes to commit. So this is readme.md file is currently in the staging file, currently to be staged. I can also take it back with reset Now it's untracked again. Want to add it, just use git add. There's also the option to use git add dot, which will add all files that are in the current directory in all subdirectories. So if you need to have always some files flying around and you just want to add them in a single commit, just use git add dot. Then you don't need to state them one by one. So now make a commit. So I say git commit minus m. M is for message, and then I can write the message. So I say initial commit. So how to write commit messages is also another sign for itself. Just don't make them so long and make them expressive of what was changed. So now it just says some stuff about what I should configure, but essentially I have now made a commit. And my git status is I'm on a clean directory now. Nothing to commit, working directory clean. And look at git log. See, there are so many commits, there's just initial commit. So say I want to make a change to readme now. The git exercise below from 25/05/2022. So save this. Okay, save this. And I could look at git status again and say it says, oh, this file was modified. Git noticed that. So I can again edit, add readme, and commit, and say edit date to readme. So one file change, 2 insertions, because I added, I think, one new line and 2 new lines, and one of them was with some text. And we're back to having a clean tree. We look at git log. We should have the other, it's up here. That's my initial commit, and up here is my new commit. Here. So far on my own system, we can also use this via remote stuff. So git remote at origin might or might not work right now because it's sometimes a bit finicky about it. And it does not like making new lines in my commands right now. What is up with my shell? Just let me relog quickly. Maybe then I get actual new lines. Okay, so where was I? Git remote at origin. My username was, I think, my username, and size. Of course, I need to move to my repository first. Shell exercise, git exercise. Then push set upstream. Okay, in my case, I initiated git with master as a main branch due to political correctness. It's now called main in the most repositories. So that's why I use it on the scripts, on the slides. But depending on how much you care about that, you can also, of course, call your main repository your main branch master. So now we'll ask for my username and my password. I don't want to add them now, but that's essentially how it works. And later, this creates a new project on the GitLab page. And you can just go to that URL, log in with as a student. You should be able to log in there with your student ID. And then there should be a new project that was automatically created for you as soon as you pushed upstream. Later, you only do set git push. And finally, you can git clone to get the project back down. I think I go over that in the exercise. There's a full example how you create it, delete your local repository, and then clone it back. Then pull the local changes, pull the remote changes. So this is a really, really quick overview of Git, and it can do a lot more. That's why I linked those two things here. So a book a community book written about Git. There are also a lot more resources about how to use Git, including its official documentation. And if you are getting in trouble and have a specific question about Git, there's also this really nice website that you can have a look at. So I will go for the last few slides, and then you have time to complete the exercises. So there's this Make. Make is a tool for making for building systems, for building software. It works similar to Bash scripts, but a bit different. It tries to be a bit smarter about it. It's also not necessary to learn it now. It's nice if you are lazy, like want to have some commands saved somewhere. You can try those out, but I won't go over them right now as we're quite advanced in the time right now. So, in summary, we did not cover networking. If you're under Windows and you don't want to use Git there, Git for Windows. And on a Bash, on a macOS, just as a hint, it does sometimes uses Sysh as by default, which is very similar to Bash, but not quite the same. So don't wonder about that. And some more resources. Okay, I would say until 12, you can now work on the remaining exercises on the sheet. So including the scripting exercise and the Git exercise. No, you don't need X to go right now. You don't need a desktop. You can just use Aria Shell, and then you can go open GitLab in your browser, in your local browser you're viewing a Big Blue Button from right now. So yeah, go over those exercises. I hope there are few advanced users or from you that had some fun with these stuff or are still having some fun with it. If you did, you can just type in and say you want to show it or you don't want to show it to keep it interactive. Otherwise, I would now let you work on those exercises until lunch break at 12. Also, for those who don't know, the GitLab page here, gitlab.ce.db.de, it forwards me you to this academic cloud page from where you can log into it using your student login. See, where's my login? Ah, here. This one, the password. Via this single sign-on, then you get overview. I already have quite a few projects going on here, but yours should also pop up somewhere in. Or you can also just make a new project via this webpage and then clone it. The important part is if you want to work on a group on this, you need to go through this webpage and add your teammates as members. So say as this one here. Didn't do with it anything. So in this interface, no, not that button, but this one here. And under project information, for the test, you can just init on the GWG servers. But depending on how you work on a later project, you might want to have it on your local system. But for the example, now you can just init draw wherever. Then have your button members under project information. So then you get members. And here you can invite other people. Like invite members and then type in their name, gives them a role developer or maintainer. Important difference is developer cannot push to the main branch of the project. So I would suggest you just make everyone a maintainer for the small projects. Okay. Are there any questions, any trouble? Yeah, of course, your local machine can break. That's why we have a remote repository. You get a bit more comfortable with Git, you can even use it to version like other documents, such as, I don't know, your thesis or something, or some paper you are working on. So it does not always need to be software. Okay, let me check that error. Say I remove me the f.git. No, I don't have a Git repository. Where was it? Yeah, get exercise. Okay. So I say git init minus initial branch equals main. Unknown option initial branch. Okay. Did I make a typo in there? Back to help. So where was it? Initial branch. Let me check it with this. Okay, I know what's the problem here. Because, let's see, git version. We have version 1831, and here we have git version 23551. So yeah, the version on this system is a bit older. And that's why it doesn't know this option yet. So yeah, just stick with master, I guess. Yeah. Okay. You can also immediately create the branch main. I think you need a few more commands to make it the main branch afterwards, but I'm not sure. Yeah, or of course you can just create it via GitLab, and then I think it automatically creates this main. Oh no, I think it asks you even, yeah. When you create it on GitLab, it asks you what to call the main branch. So if I would, was it create a new project, say GitLab, new project, create a blank project, then you can give it a name. Yeah, if you make it private, you need to authenticate every time you want to clone it. Depending on what information you put in there, you might even want to make it internal or public. With public, be careful. Do not put any credentials in there, because everything you put in there, and if you make it public, or even if you make it private and put other people in your project, they can see the stuff you put in there. So make sure in those files that you commit, there are no credentials. Things like git ignore to ignore those files automatically. So test private, initialize with that, create project. Then is my main branch. Okay, then it's automatically called main if you create it here, yes. And it puts in a long readme on how to use it. Okay, it's past 12 now. I won't keep you if you want to grab something to eat, because lunch break has